Hey, everybody. It's May 2nd, 2022. This is the spring semester 2022 at College of the Sequoias. And this is our final lecture in Introduction to Statistics, Math 21. And it is on ANOVA, Analysis of Variance. This is chapter 13, section 1. And it's called Analysis of Variance. Now, normally I would only capitalize the first letter of it, each word, but this leads to the shortcut name ANOVA. So it's called the ANOVA, and we're going to be looking at OneWay, the OneWay and ANOVA test. So the OneWay ANOVA test is for, if you recall how we've been doing the other chapters, the previous two sections have been on populations of 3 or more. We looked at or proportions with 3 or more. We did the goodness of fit test where one population could have a bunch of different proportions for each subcategory. And then we did it where there was more than one population and more than one subcategory. But those were all proportions. The ANOVA test gets down into the means test. So this is a 3+ population means test. Okay. So let's say there are K population. Well, let's just leave before I do. Let's get this at the top of your lecture notes. What you do when you want to do it is you're going to go for StatCrunch. We're going to go stats, ANOVA, OneWay. We have stats, ANOVA, and you will see when you do it, it says OneWay. So if we click on it, we can see what it kind of asks for. And it asks for us to select the columns where stuff is located at. So at this point, select the columns with the data. And we'll do that in a second. Let's just talk about what the test does. If we have K different populations, what we're doing is we are checking for equality in the means for all of them. Checking if the means are equal across all of them. Why does that not show very well? So not really. So if what that really boils down to is if we've got mean 1, well, mean 1 should equal the mean 2, which should equal mean 3, which should equal all the way up to mean K. So the subscript here is the population group number. And we've seen that before. We did N1 and N2 for proportions. And that just so happens to be our H0. Remember, in our 5 steps, only one thing changes. H naught and HA change. So we at least have mu showing up in our H naught here, as opposed to the goodness of fit test and the contingency table chi-squared test of independence. At least mu shows up here. HA, kind of like the other tests, it didn't have to show that they were all unequal, just as long as one of them is different. At least one mean is different than the rest. This test does not indicate which mean that is. So all means are equal. At least one mean is different. Give you a second to write that down, then we'll talk about the requirements of the ANOVA test. If you need this up longer, just say so and I'll put it back. So what are the requirements for the ANOVA test? Oh, I'm guessing that's a call to have it back. Yep, I definitely can. So Gabe, bring it back right now. Put a little weight on it so it doesn't want to blow away in the fan. Shit. Bump the camera around while I F up your lecture. Why is that so bright? Got it. All right. So the requirements for the ANOVA test. Well, we need K different populations. They need to be different. And we're going to have just one sample group from each. And when I say different, what this kind of means, kind of leads into B. Different means they are independent of each other. We want the probabilities to have a normal distribution, or the, let's see, populations to have a normal distribution. Populations are normally distributed. And a lot of times we don't know the distribution of the population. So if this distribution is unknown, we had the similar requirements that we wanted for the means test. So the means test, we wanted a probability plot or QQ plot to show linearity. To show that it's linear. And we want our box plot to have no outliers. So a lot of that is familiar or makes sense. Like we haven't done K different populations before, but if we're doing it now, it kind of makes sense that we want them all to be independent. We've talked about having normal distributions this whole semester, so that's not a big shocker. What is different though is the final one, category D. And in category D, we have probabilities have approximately the same, I'm sorry, the proportion, let's try this again. The populations have, I can't write to save my life. Populations have approximately the same variance. And it's been a while, but when we were talking about students' T distribution, that was one of the things we didn't know about the purport of the population. We don't know about the population, so what we do about it is we check the variances of the samples. And so we want the variance, not variance, we're gonna variant, since variance is standard deviation squared, we're gonna compare S's. So we want the largest S or the largest standard deviation to be less than 2 times the standard deviation of the smallest category. And that might be a little bit confusing, but let's say the standard deviation, for example, let's say we have S1 equals 3, S2 equals 4, S3 equals 5.5. This is the largest variance at 5.5. This is the smallest. Is 5.5 less than 2 times 3? 5.5 is less than 6. We can use the test. Leave that up for a little bit. All right, if you need it up longer, let me know. So we need that, I'll rewrite that again here. S largest needs to be less than 2 times the standard deviation of the smallest. Or the smallest standard deviation, I should say. And the way we check this in StatCrunch, recall, we can do stats, summary stats, columns, and then choose our groups and standard deviation. Standard deviation. So that is something we may need to check. We should check this. So maybe I'll put that here, things to check. Things to verify. We're going to verify our standard deviation requirement. We will verify our box plots and our QQ plots. And I am about to, well, I already have it loaded up on the screen. The problems are in that we're going to look at. We are looking at the online lecture notes for this chapter. 13.1 ANOVA. And this data set is in StatCrunch. You can, it's open for like download. If you want to look at it later, you just look up data sets. And the name is Jones. You can see it at the top. Jones Hefe, chapter 13.1 ANOVA. I'm going to do the test real quick just to show what pops up on the screen. I want to show you what some of the stuff means. We'll be doing this one in a second. I'm just going to click compute. I wanted to tell you what some of the stuff means. We've seen stuff like F-stat and p-value before. We haven't seen SS and MS. So, or we've seen DF too. DF is degrees of freedom. But SS is the sum of squares. And MS is the mean of squares. And since the mean is just the sum divided by the standard deviation, or not the standard deviation, n, this would normally imply that MS is, you would think it's, MS is the sum, because mean is sum divided by sum over total. So you would think this would be the sum of squares over n, but it's not. This is the sum of squares over n minus 1, which is the sum of squares over degrees of freedom. I'm just showing a connection between the two columns. So like if I do the error column, let's see if it shows up here. The error column, let's see if I can put that under the. There we go. So the error column is right here. I did the 493.25774 divided by 21, the degrees of freedom. And the answer I got is the mean of squares. So you can see where they got some of the figures. But is that of any interest to most of you? Probably not. It is handy to know what the hell those things mean. I'll give you guys a minute with that, and then we'll start looking at an example. In fact, I can put the first example up, the one we're looking at. I wonder if this camera thing has a contrast setting. I wonder if that's it. All right, so let's take a look at this first problem. The first problem we're going to look at is the mean rates of return for stocks. So a stock analyst wondered whether the mean rate of return or what you get back depends. I see a chat thing. Yep. Sorry, Giselle. Let me put it back up. Okay. So a stock analyst wonders whether the mean rate of return on financial, energy, and utility stocks differed over the past 5 years. Mean rate of return is like, if I invest $100, what percentage have I made or earned on that over the next time frame? And that's, so a higher number means you earned more. Rate of return is what's returned back to you on your investment. So he kind of wants to invest in the one that is the best choice. And he wants to see which one kind of is. So he obtained a simple random sample of 8 companies from each of the 3 sectors and obtained the 5-year rates of return that are shown below as a percentage. And the question is, are the mean rates of return different at the 0.05 level of significance? All right, so this has got 3 categories and it's asking about the mean. So we've got 3 categories or 3 populations, the different types of stocks. And it's a means test, so we're going to do our ANOVA test. Okay, so we need to make sure, we need to test a few things. Let's check our requirements first. The first one we check, are the variances approximately the same? So this is the S largest is less than 2 times S smallest. That's a good question. So I'm going to go test it. I'm going to do stats, summary stats, columns. And we'll look at the 3 groups. And I want to know about standard deviation. And it looks like my largest is 5.12. Is 5.12 less than 2 times the smallest is 4.53. Well, 2 times 4.53 is about 9.06. 5.12 is less than it, so we meet that one. Then we'll go through and we'll check our box plots for each group. And none of them show any outliers. So that's good. Box plots read up well. And we'll take a look at our QQ plots. Financial looks like approximately a straight line. Energy looks like it's approximately a straight line. And utilities does too. So they all look kind of good. So the QQ plots look good also. Which means that we can start doing our test. So our test is H0. I'm going to say mean of financial equals mean of energy. I'm going with the first letter of the category equals mean of utilities. That'll be my H0. And then my HA is at least one mean is different. Now the problem gave us alpha. Alpha was 0.05. And we will use stats, ANOVA OneWay for our test. Choose our 3 categories. We had them up just a second ago. You don't need to choose any of the other ones. Oh, look at that. It does a dot. We could have done the dot plot. We could have done the QQ plot right here. Look at that. I might start doing that in the future. Save some time. Who knew? And what we're looking for is our F-stat and our p-value. So my F-stat is 2.077, and my p-value is 0.1502. So what we do from there, we make a decision. Remember, we got to compare p-value versus alpha. 0.1502 versus 0.05. So p-value is greater than alpha. If the p-value is too low, we reject the hoe, but if it's not too low, we don't reject the hoe. So we do not reject H0. Do not support HA. That's our decision. And our statement is about HA. HA was the mean rates of return are different. So we make our sentence. The nots go together. Do not reject. Do not support. There is not enough. And not enough evidence to support the claim that the mean rates of return are different. For the stock categories they select. All right, if you need it up longer, let me know. Otherwise, we'll move on to another example. Notice in this last group, we had n was equal, the same group size for all the groups. That isn't a requirement. It was no, we didn't list it on the requirements. It was just coincidence for this problem that the group sizes were the same. On our next example, they're not. So our next example is on racial discrimination in purchasing. In car buying, to be specific. So the problem reads as this. To determine if there is gender and or racial discrimination in car buying, Ian puts together a team of 15 white males, 5 white females, 4 black males, and 7 black females who were each asked to obtain an initial offer price from the dealer on a certain model car. The 31 individuals were made to appear as similar as possible to account for other variables that may play a role in the offer price of a car. The following data are based on the results in the article, Fair Driving, Gender and Race Discrimination in Retail Car Negotiations, found in the Harvard Law Review of 1991. And the numbers given represent the profit on the initial price offered by the dealer. Use alpha equals 0.05 level of significance. So let's just make sure we understand how that's what's working here. Profit on the initial price offered by the dealer means there's a set price that if they sell it at this price, they make no money whatsoever. It's zero profit. It's like the cost price for the car, and anything above that price means it's a profit. So let's say the car goes for $25,000. It takes $25,000 to make. If they sell it for $26,000, they make $1,000. If they sell it for $30,000, they make $5,000. So obviously the bigger price they want to go for is the bigger the price, the more profit. So they send in 31 individuals of 4 different categories: white men and women, black men and women, and they just want to see what the initial price offerings are for each group. They sent a lot more white males than black males, 15 versus 4, but again, the size doesn't matter as long as everything else works. So they want to know if there is racial discrimination or gender discrimination. Well, this is more of a combination of both, since they got the categories together like that. So what we could do is treat each of these groups as a population, and we can't use any one price, but we could use the means of their prices. So this is going to be, we've got 4 populations here. This is 4 populations, and we're going to do a means test because proportions test doesn't make sense. So mean is going to be the average cost or the average price they sell for, and we can compare those. So if there's no discrimination, everybody should get roughly the same sales price, which means H0 is going to have the mean sale price of WM is the same price as black males, which is the same price as white females, which is the same price as black females. HA, at least one mean is different. Remember, we got to do our tests. So we want to check S large, is that less than 2 times S small? And we want to check our QQ and our box plots. I have alpha written down. Let me write that down real quick. Put my p-value here, and we got to do our F test over here. But let's do our tests. Let's do our summary stats, columns. We're going to choose our 4 groups. I need to compare the standard deviations, but I'm going to take a look at the means and see if I can get an idea of what I think is going on. Because it's kind of nice to have a good idea of where this is going. So I'll check first thing we check is our smallest standard deviation versus our largest. Our smallest is 157. I'm sorry, that goes over here. That's on the right. We need 2 times 157. Is that more than the largest standard deviation at 241? Well, 242 if I round appropriately. 2 times 157 is 304. So 242 is less than 304. That's correct. That'll work. Now, looking at the tests, or the mean, not the test, the means. If I look between races for each group, like white male versus black male, the white male is 829 versus the black male is 1500. And then if I check females, the white females are around 800, the black females around 2000. There definitely looks like there's some gender discrimination there, or racial discrimination there. If I look at the white category altogether, this one's 800, this one's around 800. Their average is around 800 together. But the black females and black males are averaging much higher. So it looks like there's discrimination by both gender and race, but that's just me eyeballing it. Is that really enough of a difference to say that, yes, there is discrimination? Because while this looks like $1,000 difference, cars go for a lot of money. Is $1,000 a lot of money relative to the type of car that they're working on? I don't know. So that's what this ANOVA test is for. But so I checked my standard deviation one. That one works. Let's check the QQ plots. Oh, let's do the box plot because it said I can do the QQ plot in the actual thing. And I can definitely see that these aren't lined up very well either, but I don't see any outliers. I don't see any outliers, but I can see the black male is a lot higher group than the white male, and the black female is a lot higher group than the white female. And the white folks have roughly the same area, while the black folks have a higher mean. So definitely, this is still backing up what I think is going to be the case. But I don't want to just look at the groups. I want some statistical significance going on. Let's see if our stats ANOVA one-way test, and we'll click on that QQ plot and see how it looks. But I'm going to select my 4 columns. And I'll do the QQ plot of residuals. First, I'm going to write down my results, my findings. My p-value is less than 0.0001. My f-test is a whopping 61.365. Well, that's kind of neat. It does all of them all at once. I like that. So they all are kind of following the same line. It's probably a better way of doing it. What happens if we look at them all individually? The group with 4 is going to be hard to tell. And, you know, they kind of look like they're on the line. I think the big one's a better residual thing. But we had our results there. And so now we get to make a decision. We're going to compare p-value, which is less than 0.001, and alpha, which is 0.05. And we have our p-val is much lower than alpha. So the p-val is too low. We reject the HO, we reject the null, which means we support HA. HA was at least one mean is different. So my conclusion is, I'm going to go back to the word problem. To determine if there's gender or racial discrimination in carbine. So that's my HA. There is sufficient evidence to support the claim. That there is gender and or racial discrimination in carbine. Any questions? No questions. All right, that's it for the new material. Let me just open up a blank Word where it's easier to type so the text is a little bit clearer than what I'm writing. Let me do large font so it shows up. Does anyone need that up longer before I start yanking shit down? Okay. So quick little summary of what to do on the final. On Wednesday, we'll walk through it a little bit better when I have your practice final fully up where we're going to use it. We'll talk about it some more then, but I want to tell everyone what to expect on the final. So our final will cover stuff from after the midterm. I just got done saying I was going to put it on this and didn't. Let's see that. Our final. Ooh, maybe let's make it bigger. Ooh. We'll cover post midterm stuff. That might be a little bit too large. Can't fit as much on there as I want. Let's make that a 30. There we go. Okay, so there, and it will be on Canvas. Along with the practice. There will be 10 questions. 2 confidence intervals, 1 for proportion, 1 for mean. So that's 2 of the questions. And we have done 8 hypothesis tests. So 1 of each of the 8 hypothesis tests that we've done. So maybe I'll start bulleting these. We've covered a 1 proportion test, or the 1P test is 1 sample proportions test. We've done the 1 mean test, 1 mu test, which is the 1 sample mean test. And that was our 2 single group tests, or single sample tests. Then we had our two sample tests. Our 2 sample tests is we had a 2 proportion test. We had a 2 means test where the data was paired, so the paired test. And in that we had N1 had to equal N2, and the stuff had to be dependent. Then we had our 2 mu tests where they were independent groups. And there was no restriction on group sizes there. They could equal each other, but they didn't have to. Then we covered our 3 tests. That was the 2 tests were chapter 11. Chapter 12 was on our 3 populations or more, our proportions test. We had our goodness of fit. Where we had like a bunch of subgroups in one category, or a bunch of subcategories in one group. We did our chi-square test for independence. And this looked like the contingency. This was the contingency table one. Where the question was, H0 was rows and columns are independent. Another name for the goodness of fit test. This one's also called the homogeneity of proportions test. So you'll see that in some of the text. If you watch other videos on it, that's another name for it. Those were the ones we did the last 2 days, and then today's test was the ANOVA OneWay. So there's 10 categories, 1 question for each. I will do all the stat crunch work for you. i.e., the test statistic and p-value will be provided. And you may assume All groups are normally distributed or pass their appropriate tests. So what's expected from you? Since I'm doing all the math for you, you got to do the hypothesis test for me. You got to tell me, first off, well, identify whether it's a confidence interval or hypothesis test, and which one. So like if it's the two means paired test, tell me which test it is. Not which test it is, but which test was used or should be used. Yeah, it was used because I did the test for you. So tell me which test was used. And when you do that, you need to, that's part one. So tell me, one, which test was used. Two, H0 and HA. Be specific. Like H0, P equals 0.32. HA, P does not equal to. Another way of doing not equals is the exclamation point. Not equal to 0.32. Or whatever it is, whatever the thing is. So you'll have to be specific. Tell me what H0 and HA are and their values. Then you've already got the alpha and the P value from the test. Make the decision. Just like I've done in every hypothesis test we've done in lecture. Compare the P value to alpha. And you're going to decide, do we go with reject H0, support HA, or do not reject H0, do not support HA. And finally, give me a statement of conclusion. Oops, I don't want to enter something there. There is not sufficient evidence to support the claim that, and then put HA in your words. If you've been doing your best to stay caught up on the homework, you've been watching the lecture videos that I make, rather than like just stuff that's on the web, or you've been, as most of you have been doing, attending this whole lecture sequence, you've seen me how I do this every single time, my 5 steps. Just repeat them. So you'll be given like a word problem, and you'll have to read through the word problem. And on Wednesday, we'll take a look at some example word problems and help build up a strategy for how you can prepare for the test or do the test well. Okay. Any questions? This should be easier than the midterm. Since most of these tests are all the same, right? The only thing that really different is the H naught and the HA. The very steps for making a decision, these all stay the same. That all stays the same. Your process here, the conclusion all stays the same. The only thing that's different is H naught and HA, and that is all very much dependent on which test was used. So we'll go through some problems and talk about how we can pick apart word problems to try to figure out what it is, because this is kind of what you have to do in real life, right? They don't tell you right out the gate, oh, this is a paired test, you should do a paired test. No, you kind of have to go, well, how do I identify it's a paired test? We'll talk about that on Wednesday. That'll give you guys a couple days to do, or at least look at ANOVA. So you'll have a little bit of practice with it, but it's not necessary. As I said, it's not in StatCrunch. Everything will be in Canvas. All right, that's all I got for you today. And as I was saying, if you guys want to ask questions, you guys can ask questions about homework, about your project. If you want, I can stop recording so that like your questions aren't in the video for others.
I don't have any questions.
All right. Well, then I will see you on Wednesday, Gabe.
Thank you, Mr. Jones.
Thank you. Glad you were able to make it every day this semester.
Yep.
Same here. I don't got any questions.
Awesome. I'll see you on Wednesday, Jorge.
All right. Have a good day, Professor
You,
Jones.
you too.